Hello everybody, welcome to class 11, Indices, Computer in Molecular Biology and Genetics 1. I am Andres Aravena, PhD. What is the big picture so far? We can write structured documents. We know that we can compile them into HTML, PDF, etc. We can also combine R and Markdown in the same document. We can handle numbers, text, and logic vectors, and we can store them in variables. What are the next steps then? In the rest of the course we are going to use real data. We will read data from files into R. We will analyze this data and produce nice plot. But we need two final pieces of this puzzle. The final pieces are based on vectors. We have spoken about vectors. So far have been numeric, logical, and character vectors. And we use them for two things. First, they will be used to contain the real data. In the next class, we are going to read real data, and the data will be in vectors. And they also allow us to look inside data. In other words, we will use vectors as indices. Indices are the hardest concept in this course. It's typically the issue where people have more problems. As we know, vectors have several elements, and we want to read, write, and modify some elements of a vector independent of the other. We don't want to rewrite all the vector if we can only change one part. And this is the fundamental idea. Just be careful, this is where people get confused. For example, if we want to access, look, or modify the ith element of a vector, let's say the third or the fifth element of a vector, x, we use the expression x brackets I. The value inside the bracket is called the index. When we speak about several index, we say indices. X of I corresponds to the mathematical expression literally x sub I. So we read this bracket as sub, x sub I. Okay, let's choose a vector for our exercise. Let's think this is the weight of some people, and we put them in a vector that we call weight. We create with the C concatenation operation. To get any element of this vector, we use a value inside bracket. For example, if we want to get the third element, we use weight bracket 3. In this case, I is a positive number, and always put the index inside bracket. Brackets are indicated when you print a vector, when you create a vector, for example, with this sequence. You see that in the first part of each row, you have a bracket that indicates the index of the first element in the row. For example, this is element number 13, this is element number 73. So in general, we can use numbers, and we can use even vectors of numbers. So if we put inside the index a vector 1, 3, 5, we get the first, the third, and the fifth element. Most of the time we are going to use range made with a sequence. For example, from the second until the 4. You get the number 2, number 3, and number 4. If we want to find the beginning of a vector, there are several ways, but the easy one is just to say weight sub 1. This is the first element. If you want to get the first 3, weight 1 to 3. Very easy. It's a little more harder to find the end of a vector. How do you know what is the end of a vector? You need to know what is the length of the vector. You remember the function length gives you the number of elements, and therefore the last element is the element in the position of length. So this expression gives us the last value. Now we can use index not only to see but also to change the content of a vector. Here we are taking the fourth value that was initially 90 and we replace with 88. We can also use negative index. This is a clever idea. Essentially, the negative number shows the position that should not be shown in the result. For example, here you have everything except the first, the third, and the fifth. You get all the rest. For example, you can take all except the first, putting an index -1, or all except the last, putting an index minus the length of the vector. you can verify that the results are correct. We can also use logic vector index. In fact, the most common usage of logic vector is to filter elements that match a given condition. For example, the values in the vector weight that are greater than 75 can be used in this formula. We can analyze it step by step. We initially have the vector weight, shown here. Then we compare with 75, and as you know, every time we compare two things, we get a logic vector. In this case, it is false when the values are under 75, and true when they are over 75. And then we use this index to look inside the original vector, and we get only the values that are bigger than 75. In this case, both vectors must have the same length. You have to verify that the length of the vector and the length of the logical vector have the same length. We can also have named vectors. What is the idea? Well, when you get these weights that represent several people, it's hard to know which is which people. So we can have a second vector with the names of the people. And we have to carry them together and be careful to have them together. Now, it is possible to put them together automatically. We do with the function names. We take weight and we assign a new value to the names of weight. We took the vector people and we combine with the vector weight, and now we have a vector with names. So we have Ali, Beisa, etc. Now it is much easier to understand who is who. How can you know if a vector has name? Well, you can see in the environment in R, or we can use the function names directly without assigning to see what is the content of the names. If we want to use name, we can even assign them at the moment of creation. When we use the concatenation function, we can assign name to each value. We do it by putting the name equal value. So we have two ways to assign names. One is when we create the vector, and the second is after we create it with the function names. You may notice that this time when we print the vector, there is no bracket. Named vectors don't show index numbers, they only show index names. Now we can do the same trick as before, and we use one vector as a filter of a second vector. We take weight, we compare with 75, some of them are going to be true, some of them are going to be false, and we use that as an index of a second vector. Since height and weight have the same length, we can do this. Remember, logic vectors must have the same length as the vector they are indexing. Now we can also use the name as an index. If a vector has name, we can use the name in quotation as an index. This is what is called dictionary in other languages. We can also use a vector of names and get all the components in the order that we choose. Please notice that this is not the original order. Here we mix it in the way that we want. Of course, as before, we can use named index to change a value, and now we take a particular person with some weight and we can change it using an index and an assignment. When you use an index to update, you can update several elements at the same time. Here, for example, we take Volcan and Fatma, we multiply their weight by 1.1, increasing it by 10%, and we assign back. The rest of the values don't change, only Fatma and Volcan get their weight increased. And please notice that the order here is not important. The only relevant part is the order in the input should be the same as the order in the output. In summary, index are super powerful. They allow us to see and modify part of the vector without changing the complete vector. Indices can be positive integers, can be negative integers, can be logic, can be character. That is the reason we have seen vectors of numbers, logic, and characters before this class. Index can be one number or more, one value or more. Except logic index, these are the only one that have to be the same size. Characters can be one or more, numbers can be one or more, logic must be the exact size.